Okay, last video ran out of time, so we're going to come back in here and finish up what we didn't get done on last video, which is just doing our nitrous acid. So the nitrite is from nitrous. Okay, so there's three endings: ic. So the ic with hydro, the ic without hydro, and then the ous. And so this is the nitrous. So that came from nitrite. We went ahead and looked up nitrite on the periodic table, and we saw that it was NO2 minus 1. NO2 minus 1. So that's what we found. So we're going to crisscross hydrogen with NO2 minus 1. So you're going to crisscross those, and you're going to get the H, not a regular looking H, NO2, because see, they're both crisscrossing a 1, so then it doesn't really matter, right? Up to plus 1, a minus 1. And so at the end, there is our HNO2. So once again, these notes, I should have said this on the first video, but just doing these on notebook paper, doing these in your notebook is fine. You can print this off. Obviously, you can write on this with your pen, but you do want to have these notes. And so that's the overview of the acids. Key things to take away from this: the idea that all acids are going to start with hydrogen is the number one thing that you need to take away. That will make sure that you're successful all the way through. And then this chart is a pain. It's something you're going to have to memorize and work with, but you'll start to see some patterns, and you'll probably start to memorize some common acids. So the HCl, hydrochloric acid, H2SO4, the sulfuric acid, the phosphoric acid, the nitrics. You'll start to memorize a few of those. So, okay, that's acids. So we're going to just jump into the next one. Just kind of ran out of time on that last slide, so that's fine. Just a blank page there for me. So the next one is really, really easy. So this is nice. You've got the molecular compound. Okay, so the molecular compound is different. Okay, so the acids were different, right? They started with hydrogen, which kind of made them unique. So then we get the molecular compounds, which are the easiest ones. But the molecular compounds, the difference in a molecular compound from what we've been working with is we've been working with ionic compounds. So we've been working with ionic. And so remember, our definition for an ionic compound was that we were going to have a plus and a minus. So it's a cation and an anion, or a metal and a non-metal. So you can think of this as the metal and the non-metal. This is what we have been doing previously. So what happens here is that there's a plus charge and a minus charge. So what's been going on, and we haven't talked about it much, is that the electrons are physically moving. So like if you have, very simply, sodium plus 1 combined with chlorine minus 1, well, the plus 1 gives away an electron and the minus 1 takes it. So they actually transfer or move their electrons. So what happens is that sodium basically takes an electron and it gives 1 electron to chlorine. So it's like, hey, have my electron. And so that's how the bond is formed. It's a transfer of electrons. And so what a molecular compound is instead of transferring electrons, in a molecular compound, the difference is the electrons are shared. So what happens is you have two negatives now, all right? So two things that are negative. So you're looking for nonmetals. And I also tell kids, think of this as things that are not metals, because it can include the metalloids. So you got two things that have a negative charge, and they are working together, and the only way to be stable is to share their electrons. So right here, the ionic compounds transfer the electrons, and the molecular compounds share the electrons. And so the difference that you're really looking for, though, is this. You're looking for in these, you're looking for 2 or more things that are not metals, or, like I said a minute ago, non-metals, not metals, all the same thing. So they're not metals, and that means if you have 2 of those, then you could be dealing with a molecular compound. So how do you identify these molecular compounds? These are formulas that contain only non-metals or not metals. Okay, so what they do is they use the prefix system. You're going to have to memorize this, guys. You're going to have to know these. You're going to learn them probably by doing problems in here. So the prefix system. And so you have to know these. So 1 is mono, 2 is di, 3 is tri, 4 is tetra, pentahexa, etc. So you're going to need to know this. You might want to write it on your periodic table for now. I do the acid rules on there as well, just to help you so you're not constantly looking them up when you're doing the work. So if you slide down here, some rules. Okay, so the first rule is that mono, which is the prefix for 1, the prefix mono is not used with the first element. So like CO, the way the prefixes work is that the prefixes are telling us how many we have. So CO is carbon monoxide, which means you have 1 carbon, and mono means 1 oxygen. So you have 1 carbon and 1 oxygen. Now, it's not monocarbon monoxide, which is always tough for students because we don't use mono with the first element. Okay, so the first element doesn't get mono. It's just carbon monoxide. You got a carbon monoxide detector in your house. Wakes you up if you've got a fire, so you don't suffocate in your sleep. So it's very important to have those carbon monoxide detectors, but it's not monocarbon monoxide because we don't use mono with the first one. Second rule, we do not crisscross these. We do not crisscross them. We do not care about their charges at all. We only use the prefixes, so there's no crisscrossing. So do not crisscross. That is a problem. So you don't crisscross. And you also don't reduce. So we don't reduce, we don't crisscross, we just use these prefixes, and it tells us exactly what we have. Okay, so let's look at this. So we've got A, which is NH3. Okay, so I have 1 nitrogen. So normally it would be mono nitrogen, but we don't use mono with the first element, so that goes away. So it's just nitrogen. So nitrogen means 1 nitrogen, which is exactly what you have there. See, this is 1 nitrogen. And then we look here, and we have 3 hydrogens. And so what the 3 is it's that little number. It's that subscript right here. That's what's going to tell me to use tri. 3 is tri. So I say tri. And then it's a hydrogen, but it's not trihydrogen, it's trihydride. So we're still changing the ending to IDE. That is consistent through all of the different types that we're going to use and name. It's very consistent. So let's go over to C. We have di-nitrogen, and we have tetraoxide. Okay, so those are the things that are important. It's the di and the tetra. Okay, so di-nitrogen means 2 nitrogens. So di means 2, right here, up here in your chart. So you're going to go N2, 2 nitrogens, and then tetraoxide. Tetra is 4, so you're going to go O4. So I'm going to leave it just like that. No crisscrossing, no reducing. So I am not crisscrossing, right? So if you look at here, I did not, I do not reduce. So I don't make them an NO2, divide them both by 2, and I do not crisscross. I don't care about their charges because they're both going to be negative. You'd have a -2 and a -3. That would be a mess. So how did I even know to use these rules? Well, if you look at these things, these are nonmetals. Nitrogen's a nonmetal, hydrogen's a nonmetal. And then the prefixes are like, hey, if you have prefixes, you got to use them. So if we go here quickly just to discuss the nonmetal thing to make sure we're good with that, the reason that we're using these molecular rules is that these items are all nonmetals. So we have to remember one thing, though. Hydrogen is a nonmetal. It's just misplaced. It's a nonmetal, as are all of the things over here along your staircase and to the right of your staircase. And so things that are over here or are not aluminum, are touching our line, those are things that are not metals. These are things that we could be using prefixes for, but you have to have two of them, okay? But key thing is that hydrogen is considered a nonmetal. It's just in the wrong place on the periodic table. So everything we've been working with is nonmetals. Everything is going to need prefixes because we don't have metals. No metals, you're going to use these rules. Maybe that's the easiest way to think of it. Just look for the metals. Okay, so here's B, phosphorus tribromide. So let's think about it. Well, phosphorus is a nonmetal, and bromine is a nonmetal. So two nonmetals, no metals at all. So let's go ahead and think through this. There is nothing here. That means 1. And this is tri, so that means 3. So phosphorus tribromide. So phosphorus is a P. And bromine or bromide is Br. And there we go. I don't crisscross. I leave them exactly where they're at. So this said dinitrogen over here. The 2 stays there. Tetraoxide, the 4 stays there. You don't move them. And the last one, carbon and oxygen, neither one's a metal. So normally it would be monocarbon, but we don't use the word mono for the first element, so that's out. So this is just going to become carbon, and then there's a little 2 there, so the 2 is up here, di. It's going to be dioxide, carbon dioxide. So the key thing is can you recognize when to use these? And so basically you're looking for a metal. If you have a metal, you can't use these, right? You got sodium, potassium, iron, whatever. But if you have things that are not metals, you use these rules. If you have these weird prefixes, you use these rules. So, okay, I'm gonna pick up the next set of notes is gonna be the hydrates.